So now we have the rational zeros theorem. So if this polynomial p of x has integer coefficients and the first term can't be 0 and the last term can't be 0, in other words, there is a constant at the end, we'll make that note, must have a constant, then it's basically telling us every rational zero, remember a rational number means it can be written as a fraction, so every rational zero of that polynomial is of the form p over q, where p are the factors of your constant coefficient and q are factors of the leading coefficient. So let's sum this up. Possible rational zeros are going to be of the form where it's factors of the last constant, just a number by itself, divided by factors of the first coefficient. A couple of notes here. First of all, the rational zeros will be in the list, but that doesn't mean that all of those numbers are actual zeros. It just means they'll be chosen from that list. I don't know why that it is there. And we also want to make sure that we include both the positive and negative factors of that first and last constant. Let's do this example here. We want to find the rational zeros of this polynomial. 2x to the fourth minus 7x cubed plus 3x squared plus 8x minus 4. When we are finding rational zeros, we're only going to focus on the first and the last numbers. So let's first look at factors of -4. Okay. And remember, when we say factors, it would be integers or numbers that multiply to give us 4. Well, 1 is a factor of 4, so we've got plus or minus 1. 2 divides evenly into 4, and 4 divides evenly into 4. No other numbers divide evenly into 4. Now we want the factors of the first number. So factors of 2, not as many, plus or minus 1 and plus or minus 2. If we're looking for possible rational zeros, we're actually going to put every number from the top there, factors of -4, over every number of the factors of 2. So for example, 1 is a factor of 4. So possible rational zeros could be 1 over 1, or plus or minus that 1 over the 2. So I got the 1 from factors of 4, and that denominator, 1 of 2, are your factors of 2. So we've used this guy. Now we're going to use this guy, factors of 4. So we can have plus or minus 2 over 1, or plus or minus 2 over 2. And now we use the 4. We can have plus or minus 4 over 1, or plus or minus 4 over 2. Now, some of these repeat. So let's clean it up a little bit. Possible rational zeros. Plus or minus 1 over 1 is just plus or minus 1. And the next one is plus or minus 1/2. The next one is plus or minus 2. But this guy here is just plus or minus 1, which we already have. So we go to the next one, plus or minus 4. And this last one reduces to plus or minus 2, which we already have. So now we're just looking at 4 numbers and their opposites. So we can use the factor theorem, plug these numbers in to see if anything gives us 0. We can also use the intermediate value theorem. If we happen to pick 2 numbers and one's positive, one negative, then that means there's a 0 in between. It may be one of our rationals as well. So looking at our original equation, we've already got some negatives in there and some positives. So I would start with easy numbers like 1 and -1, see if anything works. So let's plug in p of 1. We get 2 times 1 to the 4th minus 7 times 1 cubed plus 3 times 1 squared plus 8 times 1 minus 4. If we combine all of that, we actually get the number 2. So that tells us that this is not a 0. Let's try -1. We get 2 times -1 to the 4th minus 7 times negative 1 cubed, plus 3 times negative 1 squared, plus 8 times negative 1 minus 4. That one does in fact give us a 0. So we know x equals negative 1 is one of our zeros. Now we can plug in each and every one of those numbers, plus or minus 1/2, plus or minus 2, plus or minus 4, see which of those gives us 0. One, by using the graph, but also by using the table.
If we did, that would give us
P of a positive 1/2 equals 0, and P of 2 equals 0. So our rational zeros are negative 1, 1/2, and 2. See you soon.